डॉक्टर शिकार मारने वाला गाने होते ये किसी ने डॉक्टर शिकार मारने वाला को ज्वाइन किया होता ना.
Good afternoon, Division 4.
Not Division 4, Division 2. Good afternoon, sir.
The division which one?
Division 2, sir.
Division 2.
Division 2. Do you have my lecture? Okay. I think division name is wrong, but I am at the right place to teach engineering mechanics, right? Let me check the timetable. Yes, this is division 2, and right now I only am supposed to teach you. Great. "24 cadets are present. Where are the remaining ones? You all are a lazy lot, I must say. You can't even log in time.
Sir, joining, sir.
Joining, fine, but this is not the way. We should begin sharp. And thereafter, sometimes, someday there can be some issue, but not always. So what all did you do in the morning? Where were you all?
In the workshop.
In the workshop. So doing what? Turning?
Sir, welding and lathe.
Welding and a lathe. Okay. So you know how to cut the threads on the lathe?
Sir, we just started with the thread, just done facing.
Okay. So you don't operate the machine so far.
Yes.
That is fine. In the welding, how much do you know? You have done the butt weld and left weld, both you have finished?
Sir, he just, the instructor just told about the T welding. The T joint.
Okay, but was it a lap joint, fillet weld, butt weld?
So that wasn't true.
Acha. Okay, but you did took an electrode in your hand and they made a welding line, right?
Yes, sir.
Okay, that is very interesting. Welding skills are very important, especially in the field of marine engineering. So by the time you will pass, you will be Lloyd's approved welders from this place, which is an enviable thing. That much. That much skill even professional welders are not having in the industry. So right now we have 31 cadets present over here, and I think we should go ahead with our studies. So you can see this now. Today we will be studying a roof trusses. Now you know roof trusses are of many kinds. They can be a on the roofs of a building. They invariably have a triangular shape, and then there are patterns like this. Etc. There are three types of a trusses: Pratt truss, Oval truss, and then there is a pink truss. I will show you all the trusses today, and we will solve one numerical based upon a Pratt truss. There are two methods: method of a joint and the method of a section. We will be, I think, deploying today a method of a joint. So here is a truss which is given to us. Total geometry and everything is given. Now work with me fast and reply me. I am looking, I will be just put a reply, I mean verbally only over here. How many joints are there in this particular truss? J is equal to how much? How many joints?
So next slide.
Pardon?
We can't see diagram. We can only see that engineer mechanics.
Oh, I think I don't know why that is happening, but now I think you can see a new diagram, right?
Yes, sir.
Okay, so here I am asking you, how many members are there in this truss? And how many joints are there in this truss? That is, M is equal to be replied, and a J it is to be replied. What is J?
So J is 12
Very good.
and members 21.
21.
Members 21. Members 21. But you should count it, not simply put 2j minus 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us see if members are 21 or not.
Sir, 21.
2, 3, 4, 5, 6, 7, 8. Right? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 members, not 21. Who counted it to be 21?
So there are 21, sir. You forgot to
Four, yes.
Which
I-
one?
EB and CB.
I forgot CB.
And
CB and
EB.
EB, sir.
Look, this I am counting 1, 2, 3, 4, 5, 6, 7.
So you're forgetting CB again.
Which one?
CB. Member CB.
Here. Yes, 11 here. Good. Now put the cameras off. Otherwise, it takes a part of the screen. Everybody should keep the cameras off, please.
Abhishek Belgaonkar, keep your camera off.
Oh, okay. Now, first thing we do for solving a truss is analyze, means we have to find out force in every member. First thing is to find out a support reaction. Support reactions are very easy to find when there is a uniformity. Look, all the loads are uniform. Here 12, center is a 12. Here also 12 and here also 12. Here also 12 and here also 12. When in such a cases, what we can do? Suppose there is a 10 here and a 10 here, 20 here and a 20 here and a 30 here. Any kind of a symmetry, load is equally shared by a joint. So here in this case, 12 5s are 60. So R1 is a 30 and R2 also is a 30. Now we had a long discussions on a zero force members. Can you see a zero force member over here anywhere? Any member which will not be taking any load? It is very easy to identify. If you have not developed that skill, you better develop it. It will not come overnight. See, this element and this element are in a one straight line. And there is a third element connected over here. And there is no force acting over here externally. There is no pull, there is no push. That means this has to be a zero force member. Okay, so GF is a zero force member. Zero force member is a zero force in this situation. Had there been a force acting over here, then this wouldn't have been a zero force member. Okay, so now we are ready to work ahead, and here we are. First and foremost thing to solve a roof truss is, you have to take a lot of cos and sine everywhere. So you should be knowing all the angles. Rather, if you do not know the angles, it is all right. I did not know what this alpha is exactly, but I should know what is a cos alpha and a sine alpha, cos beta and a sine beta, cos theta and a sine theta. Now this is alpha, this is beta, this is theta. If this is theta, this is 90 minus theta, so no need to worry. This is 90 minus beta, no need to worry. Okay, if I draw a line here, this is beta only, this is alpha only, and draw a line here, this one also is a alpha. Everything is only three angle we have to define. Don't define this as a phi and find out phi also. Okay, everything is not required. And the best method to find out angle is its tan will be very much prominent. This is alpha, this is 4, and this is 6. So tan alpha is a 0.666. Moment you get a tan alpha, finding this is very, very easy. Tan beta. Tan beta will come from here simply this much divided by this much. This is 2 meter. How much is this? That you have to find out quickly from similar triangles. This is a one triangle and this is a second triangle. This is 4 by 6 is equal to this much divided by 4. Okay. This is height is a 4 divided by 6. So this much divided by 4. So 16 by 6 or 8 by 3. This height is a 8 by 3. This is 2. So tan beta is a 8 by 6. So 4 by 3, 1.333. So cos beta and sin beta are also given over here. Then theta. Theta is a 4 by 2. So tan theta is a 2. So cos theta and the sin theta are also known already. It has been done. Now, once you are ready with all the angle, let us go by the joint. Our first joint is a joint A. Or we can start with the joint L also. It is up to us. We have to decide what we want to do. Okay. So, we are at a joint A. Now, this is a joint A here. Remember, at A there is a member AC connected and a member AB connected and this force is connected. So that only thing is to be checked. Remaining things are not to be worried. We have to look upon this much part only. And what are the forces acting at a point A? AC is connected with A and on AC also there is a force 12 working, but that is not to be considered. We have to look at the equilibrium of a joint A. So we are concerned with the forces acting at a point A only and nowhere else. So right now I have identified, separated a joint A as you can see. This is a joint A. This is a member AB and a AC and this is a member AB. Now friends, only one force is acting over here. There is a force in a AC also and a AB also. We do not know. Maybe AC is pulling it or pushing it. AB is pulling it or pushing it. I do not know. See, there are three forces. Force in a AC, force in a AB and this 30 Newton. For this force, direction is known and the magnitude also is known. Over here, only direction is known, magnitude is not known. Here also direction is known, magnitude is not known. Now direction can be forward or a backward also. But we assume that directions are radially outward. This is only a assumption. See, AC will pull a joint A. AC will pull a joint A provided AC also is being pulled. So if AC is in tension, I am assuming that AC and the AB both are in tension. Okay, we'll work it out now. Now, sum of all the forces over here is 0. That means sum of the x component is 0 and the sum of the y component also is 0. As a result, what we can do? This is the y direction. Here AC has a upward component which will be AC sine alpha. So F AC sine alpha plus this 30 is equal to 0. So F AC is a minus 54.083 kilonewton. F AC has come negative. What does it mean? It only means that direction assumed radially outward was wrong. It should be radially inward. Okay, fine. Now, sum of the forces in a x direction also is 0. So, force in a AB plus force in a AC. So, FAC cos alpha plus FAB is equal to 0. So, FAB will turn out to be 44.997. Remember, FAC is to be put negative. So it is negative over here, it becomes positive on that direction. So now we are also aware of a magnitude of force in a AC and a AB both. This 44.99 kilonewton has come positive. So this assumed direction is correct. It is not wrong, and we can work with that. Is it clear to everybody? Does anyone want a debate on this? Would like to know something further? Anyone? No, it seems. Okay, so now we come to the next joint. Our next joint is a joint C. Look, dear friends, we finished this joint A. Now we can come to the either joint B or joint C. I prefer to come to the C. Why? Because C has only 3 forces working, out of which we know a one force very, very well. And then this external load also is known to us. So finding a load in the this and the this will not be difficult, merely by a 2 equations. So now pay attention here. This is the external force. Force in a AC we have calculated earlier. AC was in compression, so it is radially inward over here. This direction and the magnitude both are known. This direction and the magnitude both are known. This direction only is known of a CE and direction only is known of a CB. Correct? So we can say sum of the x component of all the 4 is 0. So we have a here X component of a AC is here AC cos alpha, and the X component of a CE is a CE cos alpha. Sum of a this and a this is 0. So FAC cos alpha plus FCE cos alpha equal to 0. So FCE is equal to minus FAC. So that is equal to minus 54.083 kilonewton. Answer came negative of a FCE. So FCE, assumed direction outward, is incorrect. It is inward. It is inward. Okay. Then this 12 kilonewton plus this forces in a y direction. Y component of a this and a y component of a this both are equal and opposite, so they are cancelling each other. So we can say 12 kilonewton plus CB is 0, so CB is a minus 12 kilonewton. Minus means this direction is wrong. Answer should be here like this. Remember one thing always, actually, whenever there are at any node, there are 4 elements meeting, and these two and these two are in a straight line, then this and this are equal, this and this are equal. If this is in compression, it will act like this. If this is in compression, this got to be in compression and it will act like this. Same way, if this is in tension, and this also will be in a tension. Always. So here, there is a one line and a second line. So AC and the CE are equal and opposite. 12 and this are also equal and opposite, that you can clearly see. Acha. Here I have made a mistake. This arrow I should have lifted up. So let me correct my mistake right away, so that that corrected one I can send it to you today itself. This is with you already. It is in a put in a WhatsApp as well as in a Moodle. It is present. Okay. Yeah. Let me just reverse it and place it here. Okay. Now we are here, and then after finishing point C, we come to the joint B. This is joint C, and then comes a joint B here, and the angle is a beta here, so we have a this table of beta ready, AB was in tension. So I am showing AB to be in total year tension.
Sir, the
FCB
slide is not visible.
not visible. Okay, I will make it visible anyhow. It is visible now.
Yes.
This is something I think I need to correct it. I hope it is not any kind of a virus, but I think the slides are vanishing. I will update my Zoom again and just see. Now, BA, BC, BD, BE. We are putting every force that is known to us on the figure. AB was in tension. We have found it out while we were working on a joint A. It is in tension, so 44.997 kilonewton. Then CB was in compression. It was at 12 kilonewton. I assume that BE and BD are in tension. They are assumed. If their answer comes positive, they are in tension. If their answers don't come in a positive, they are in a compression. Correct? Okay?
Yes, sir.
You can very well understand now. Sum of the forces in a y direction is 0. So FBE, what are the forces in the y direction? This CE is downward minus 12 negative. Then BE is like this. Its sine component will come over here. So FBE sine beta upward positive 12 is a minus 12 is equal to 0. Okay, minus 12 is 0. So now FBE is a 12 divided by sine beta. Sine beta is a 0.8, so this is a pakka answer 15. 12 divided by 0.8 is a 15, I think. Or am I wrong? Yeah, it is 15 only. Right? And 15 came positive, so assumed direction also has come to be positive. Okay, then we have to deal with the FBD. FBD. Correct? If that is a FBD, then what will be the balance in a x direction? X direction is a FBD plus FBE cos alpha, because it will be a cos alpha here. So the cos beta. This is not sine, this is cos. Okay, which is 0.6 and minus this minus FAB equal to 0. So FBD will come to be 35.997. You just check if I am right or not. I think I printed here sine beta, but actually it is cos beta. Just tell me if it is right or wrong. FBE and FBD. It seems you are not interested in participating, so we go ahead, and now I will have to create some soft pressure on you so that you participate. How will I do it? I will do it like this. We were here, cos beta. It is correct. Here it should be. After finishing a joint B, A, B and C, we can come to the joint E over here. I am showing joint E only, which is repeated over here. Now what we can do? We can leave that as it is and remove remaining things. Gone. This one also is gone. This is not doing anything here. This angle is alpha. Theta doesn't come in here. This also is alpha. So this is a situation. Now I encourage all of you to find out the forces. How will you go about it? There is a alpha and a beta here. So we need the table of a alpha and a beta both. But this theta we don't know, don't need. So I am removing it. This also is a something not required. Out of this, how many forces are known to us already? E. BE is a 15 kilonewton tension. BE is in tension, so we can say yes. Here is the BE. BE is making a angle beta over there. And the value of a BE also is known. Now we have solve the joint C also. We have solved the joint C as well. Let us go to the point C. This is C. CE is a tension. CE is in compression, sorry. Minus 54.8 FCE. So CE is in compression. And let us assume, we assume that remaining are in a tension. ED also is in tension. And the EC also is in tension. EG, that is, sorry, not EC. This is FBE. Which is 15 kilonewton. Which I am showing over here. Which is retention, of course. Excuse me. Then FCE. FCE is removing a minus sign because over here we will be considering it FCE is a acting inward. Now this is 54.08 acting at a angle alpha. This is acting at a angle beta, and this is a 12 kilonewton. So we need to find out EG and ED. I encourage all of you to find it out. Now, who is confident of, okay, let us not find it out, but who will tell me, Belgaonkar, can you find out? You know it already, how to do it? Abhishek Belgaonkar, are you here in the class? Ronak Badarka, Ronak, are you here in the class? Cadet Patidar, is anybody listening to this? Who is that? Patidar, okay.
Yes, sir.
Patidar, can you find out CE now? And we have two unknowns. What are the unknowns? This
Sir, I
E.
will try.
Oh yes, very good. That is the perfect answer that I will try. EG and the ED. Now let me tell you, if anybody will give me value of a EG and the ED, and the waves they are in tension or compression in next 5 minutes time, then between you and me, even if you bungle up your trust problem in an exam, I will give you full marks. Suppose a 10-mark problem, you bungle it up. But today, if your correct answer is there in front of me, of a node E and the next node which I am going to take it to, then right now if you put a correct answer and don't tell anybody, I am going to give you a full mark. Because right now you are alert and you are paying attention, that's why. And I have noted, I took the 3 names earlier. Out of 3, 2 are sleeping or they are not bothered to answer me, whatever. Anyway, those who want to remain alert, kindly start working and tell me the answer.
Maybe.
Sir,
Yes.
can I try the answer?
Pardon?
I have the answer.
You've given the answer.
Should I say it or type it?
You send it to me. Where have you sent it to me?
Sir, I sent it on the Gmail.
On Gmail. Where?
I sent it on Zoom, sir.
On the Zoom. On a chat box?
I'm sending it, sir.
Okay. Okay. All of you now can do one thing. You have this already. Anyway, I'm happy that at least one cadet tried. Okay, Sahil. Sahil is a CR, right? Sahil, where are you? Are you here in the class? Huh? Who is CR?
064 Animesh.
Animesh.
Yes, sir.
Okay. There seems to be, I got an answer. One is a, yes, 43.26 compressive EG. Another one? Other answer? I think everybody else is finding it too damn easy. So you're not attempting it. But I'm glad that one cadet has given me one answer. FEG is equal to 43.26 compressive. Now I expect another answer also, but it is not coming. FEG.
Sir, can you show the diagram for a second?
Huh?
So the diagram.
Here. FEB is 15. I'm surprised why only one candidate is trying and not others. What is the reason? CR sir, just send me the WhatsApp of a 3 candidates who are absent.
So all are there, 33 are there.
33 including me. So 32 candidates are here.
Yes, sir. And that one boy, Manthan Hatte's division has been changed. And
So
one,
now, what is the class strength now?
so 33.
33. So one candidate is absent in that case.
Sir, one has gone on medical leave. His hand has fractured.
No problem. Just send me his number. He is on medical leave or whatever is the reason.
I will send.
It is just a record that I know that he has not studied the trusses from me.
Okay, sir.
Huh? Yeah, okay. What happened? How he fractured his hand? What happened to him?
While practicing in football.
My God. So from where was he? Which town he belonged to?
Yes, sir.
Acha, FED is a 41.9. I'm checking it. Cadet, I swear, if these answers are correct, when I find out, just remind me after writing your exam that I owe you a full mark into a problem. You are a Devish.
Yes, sir.
And 8056. Good. Nice try, Devish. It hardly matters whether you are right or wrong. What matters is that you are active in the class, and that delights me very, very much. It is 1531. Daksh is saying me that FEG is at 21.18. Okay, Daksh. I'm saving this chat and I will look into it. Okay, now time for you to go to the next lecture. I enjoyed this experience. I hope all of you also enjoyed as much as I did. If I want to leave the meeting, then Aditya, you are a host now. You can make a coming professor a host. Have a nice day, all of you. Jai Hind.
Sir, Srikanth sir is there.
Shrikant.
Am I audible to all of you? Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Yesterday, I given you some homework problem. One homework problem I given to you yesterday.
Yes or no? Let me share my screen. Division 1 is also joining. Okay. So this is the combined lecture for Division 1 and Division 2. So who is the co-host? Animesh, I will make you the co-host. Please confirm the student and let them in the class.
Yes, sir.
Okay. So this is the problem which are given to you, Division 2, yes? Yes or no, Division 2? Yesterday we discussed this problem.
Sir, you didn't take the lecture yesterday. There was no class in our division.
Okay, okay. That means these are completed for the division number 1. Okay. I think after evening class, I was not able to conduct.
Random class पांच चला.
Yeah, yeah.
हमारी जात की अलग साइड नहीं है.
Hello.
औकात में जान बनी है.
Hello. Okay, so this is the combined class. So we'll solve a different problem. Okay, so that all this problem will be different for the both the division 1 and division 2. So I'll quickly go to the problem statement. I think this problem, this is the unsolved problem which are given to the division 1. So let's take this problem and then we'll move on the other problem. In this problem, they given the power developed by a turbine in a certain steam plant is 1200 kilowatt. The heat supplied to the steam in the boiler is 3360 kilojoule per kg. The heat rejected by the system to the cooling water in the condenser is 2520 kilojoule per kg, and the feed pump work required to pump the condensate back into the boiler is 6 kilowatt. And they ask calculate the steam flow around the cycle in kg per second. So first we must know the thermal power plant. What we generally used to have in the thermal power plant. In thermal power plant, we used to have the 4 different devices. First, we call as a boiler. This is called as the boiler. Then after the boiler, we will have the turbine. We will have the turbine. Okay. After turbine, we'll have the condenser. We'll have the condenser. After condenser, we will have the feed water pump. So this is the boiler, this is the turbine, this is the condenser, and this is the pump. So function of boiler is to convert the water into the steam, and for that purpose, the boiler is consuming the steam, okay. And in order to develop that steam, the 3360 kilojoule per kg of the heat is rejected, okay, by the system. That means there is a Q in. So this is what we can say Q in, that is called as 3360, okay, kilojoule per kg. Now after rejecting the heat is rejected to the cooling water in the condenser is 2520 kilojoule per kg. And here from the condenser, what is the function of condenser? Function of condenser is to create the condensate. That means to convert the steam into the water. So whatever the boiler convert the water into steam, that steam will do the work, okay, on the blade of a turbine, and turbine will produce the the work output. So this is the work output. And this steam, after doing the work on the blade of a turbine, will move inside the condenser. And function of the condenser is to generate a condensate. That means heat is rejected. That means Q out, it is moving out of the system, is 2520. Is 2520 kilojoule per kg. Now, they mention a power developed by turbine in certain steam power plant is 120 kilowatt. So the power developed is nothing but equal to 1200 kilowatt. That is called as the power output from the turbine. And after the feed water, after the condenser, the whatever the condensate is there, that condensate we need to move with the help of the pump again back to the boiler. So we require to consume some work in order to operate the pump. That means there are the 4 different processes. First is nothing but called as Q in. Second is nothing but called as work out. Second is nothing but called as work out. Third is nothing but called as Q out. And fourth is nothing but called as W in. That is called as work in. Okay. So here in this case, what is given to you? What is our first law? First law is cyclic integral of dq is equal to cyclic integral of dw. Okay. And what is dq? dq is equal to q in minus of q out. That means 3360 minus your q out is 2520. Okay. So this is nothing but called as your cyclic integral of dq. So what is their unit? Unit is kilojoule per kg. So it is 3360 minus 2520 is nothing but called as 840. Okay, kilojoule per kg. This is nothing but called as your dq. But when we call about the power, but when we talk about the power or work, the work is given into kilowatt. That means 1200 kilowatt, and W in also given in the as 6 kilowatt. Okay. So unless and until the kilojoule per kg, if it is not multiplied by m dot, we will never get kilojoule per second. Okay. So this 840 must be multiplied by your m dot. So we can say that the cyclic integral of dq is equal to m dot 840, and in this way we converted unit that kilojoule per kg into kilojoule per second, which is nothing but in kilowatt. Now, what is cyclic integral of dw in this problem? In this problem, the cyclic integral of dw is equal to 1200 minus of 6. That means 1194 kilojoule per second. That means a kilowatt. So we can say that the cyclic integral of dq is equal to cyclic integral of dw. So dq is equal to m dot 840 is equal to 1194. So from this we are able to get the value of m dot in kg per second. So 840, the answer 840 divided by 1194. So 0.70. Is it okay? 840 divided by 1 point.
m dot निकाल रहे
हाँ
तो फिर 1194 डिवाइड 840 नहीं है
So 1.42.
1.41 है
So 1194 divided by 841.
हाँ 1194 divided by 840. I think it is 1.421.
Yes,
yes
sir.
sir
1.421. Yes. 1.421. Now here, one thing we need to understand that the unit must be same. In first case, they given you the unit in kilojoule per kg, and in this for the second case, they given the unit as a kilojoule per second. that means in kilowatt. So it is not possible for you to equate cyclic integral of dq with cyclic integral of dw. Okay, so because of that, the dq must be multiplied. That means kilojoule per kg we need to convert into kilojoule per second. Okay, so because of that, it is multiplied by your m dot. So when it is multiplied by m dot, the kilojoule per kg will get converted into kilojoule per second, that is kilowatt. So left hand side is in kilowatt, right hand side is in kilowatt, and we are able to get m dot into what we can say 1.421 kg per second. Getting all of it with me? Yes or no?
Yes, sir. Sir, can you explain that m dot again?
Question is नहीं आया m dot.
m dot
Sir,
क्वेश्चन नहीं समझा आपको? देखिए
I need
आपको
solution.
अच्छा, मैं फिर से समझा दूं आपको. द स्टीम पावर प्लांट आपको दिया है. तो स्टीम पावर प्लांट के अंदर 4 इक्विपमेंट होते हैं: बॉयलर, टरबाइन, कंडेंसर एंड द पंप. व्हाट इज द फंक्शन ऑफ बॉयलर? Function of boiler to convert the water into the steam. Okay, the steam will do the work on the blade of a turbine. Now in order to convert that water into steam, we used to fire the coal. That means heat. We are supplying the heat to the boiler. What is that heat? Is nothing but 3360 kilojoule per kg. This much amount of the heat is supplied to the particular boiler. Now whatever steam is produced, that steam is doing the work on the blade of a turbine. That means there is a production of work output. Okay, what is that work output? Is nothing but 1200 kilowatt. It is a kilojoule per kg. Okay, and this is kilowatt. What is kilowatt? Kilowatt is nothing but called as the kilojoule per second. Okay, so unless and until the kilojoule per kg multiplied by kg per second, that is m dot. Okay, then the kg will get cancelled and you will get the kilojoule per second. So here, if you want to convert the kilowatt in kilojoule, if you want to convert a kilojoule per kg into the kilowatt, then in that particular case, what is kilowatt? Kilowatt is kilojoule per second, and if it is multiplied by kilojoule per second, now that means kilojoule per kg, if it is multiplied by m dot, what is m dot? Mass flow rate. Mass flow rate is kg per second. Kg per second. So kg will get cancelled. So in this way you can get the unit called as kilojoule per second. And because of that, here for the dq, cycle integral of dq, the 840 is multiplied by m dot, and when it is multiplied by m dot, you will get the unit in kilojoule per second, that is in the kilowatt. Okay, now what is q out? That is condenser, is nothing but 2520. That means this much amount of the heat is rejected to the cooling medium. Now what is work in? Work is nothing but called as, what we can say, the work which is absorbed. So that means two devices are there in the system. Those are associated with the heat transfer, and two devices are in the system which are associated with the work transfer. So what is the first law? First law is that cyclic integral of dq is equal to cyclic integral of dw. So dq कितना है? q in minus q out कितना है? 3360 minus 2520. तो ये हो गया आपका 840 किलोजूल पर केजी. और हमको किलोजूल पर केजी में चाहिएगा ये नहीं, हमको किलोजूल पर सेकंड में चाहिए. इसलिए 840 को हमने 8 m डॉट से मल्टीप्लाई कर दिया, यानी किलोजूल पर केजी. ये यूनिट को हमने किस में कन्वर्ट कर दिया? किलोजूल पर सेकंड. ओके, यहाँ तक हमारा स्टेप नंबर 1 हो गया. ओके, स्टेप नंबर 2 क्या है? डीडब्ल्यू. डीडब्ल्यू क्या है? किलोजूल पर सेकंड में ऑलरेडी है, दैट मींस किलोवाट में है वो. दैट मींस 1200 माइनस 6 इज 1194. तो ये हो गया हमारा स्टेप नंबर 2. इक्वेशन नंबर 1 इक्वल टू इक्वेशन नंबर 2. तो हमको क्या मिल गया? m डॉट 840 इज इक्वल टू 1194. ओके, तो हमने इस पर से हमारी वैल्यू निकलती है m डॉट. दैट m डॉट इज इक्वल टू 1.421 kg per second. समझ में आया अभी?
Yes, sir.
Now next part.
Can you please scroll up?
और ऊपर go?
Yes, sir.
Okay, you want to note down the problem statement?
Yes, sir.
Yeah, please.
सर वो 1200 कहाँ से आया था? 1200 minus 6.
1200 ये है वर्क आउटपुट है, 1200 यहाँ पर किलोवाट में. ओके, ये पावर प्रोड्यूस कर रहा है ना, टर्बाइन ऑलवेज यूज टू प्रोड्यूस द पावर एंड पंप ऑलवेज यूज टू कंज्यूम द पावर। तो टोटल वर्क ट्रांसफर कितना हो गया? 1200 माइनस 6 हो गया यहाँ पर।
Yes, sir.
Okay, finish all of you. Can we move on?
Yes, sir.
A cylinder contains, write down, 0.45 meter cube of gas, contains 0.45 meter cube of gas at 1 into 10 to the power 6
Sir, sir.
six Newton per meter square and 80 degree Celsius.
सर
Yes.
सर आप एक ऑफलाइन क्लास ले लो ना सर, न्यूमेरिकल का वो लॉजिक समझाने के लिए थोड़ी दिक्कत आती है सर जब खुद से करने बैठते हैं तो।
Yes, sir.
सर बस 1 या 2 क्लास ले लो सर ऑफलाइन, वो बस न्यूमेरिकल का पैटर्न समझा दो। ऑनलाइन नहीं आता सर बिल्कुल भी समझ में अच्छे से।
ऑफलाइन कॉलेज में परमिट करना चाहिए, कॉलेज ने अगर परमिट करता लेंगे हम।
ऐसे मतलब ईयर कोऑर्डिनेटर वगैरह से बात करके 1-2 ही रखवा लो, मतलब ऐसे ही तो सही रहेगा सर थोड़ा।
हाँ कर सकते हैं, बट वी नीड टू टेक परमिशन फ्रॉम कॉलेज। मुझे दिक्कत लग रही है अगर वो परमिशन देंगे या नहीं देंगे।
सर हम एप्लीकेशन लिख देंगे सर, साइन है।
हाँ
सर अगर हम एप्लीकेशन लिख देंगे सर, सिग्नेचर सब करके डिवीजन पूरे स्टूडेंट।
हाँ पर आपको इधर इसमें क्या दिक्कत आ रही है अभी? ये पिछला वाला प्रॉब्लम नहीं समझा आपको?
सर वही तो सर समझ में आ जाता है, अभी ऐसा लगता है समझ में आ, जैसे हम खुद से करने बैठते हैं सर तब नहीं बनता सर।
हाँ तो वेराइटी ऑफ प्रॉब्लम हम पहले टैकल करेंगे ना। हम वी नीड टू एड्रेस द वेराइटी ऑफ प्रॉब्लम, सो आफ्टर कंप्लीशन ऑफ दैट टॉपिक यू विल एबल टू कम टू नो। अभी वेराइटी कहाँ पर कंप्लीट होगी हमारी? बेसिक प्रॉब्लम तो हमने ली है। जैसे ये कल का डिवीजन 2 का ये प्रॉब्लम नहीं हुए है, तो ये प्रॉब्लम हम जब कॉमन आपका क्लास होगा कल तो ये प्रॉब्लम हम लेंगे उसके अंदर, Q इज इक्वल टू डब्ल्यू प्लस ऑफ डब्ल्यू के वगैरह। आपके इसमें कितने प्रॉब्लम हो गए? 3 या 4 प्रॉब्लम हो गए ना डिवीजन 1 के अंदर, डिवीजन 2 के अंदर।
सर
4 हुए थे सर, इसका भी सेकंड पार्ट पता नहीं हुआ था नहीं हुआ था।
हाँ 4 प्रॉब्लम हुए थे ना स्टार्टिंग के।
हाँ सर ये हो गया था, 6th वाला सर इसका पहला पार्ट कर लिया था। हाँ सर
ये हो गया था ना।
हाँ सर इसका पहला पार्ट कर लिया था शायद से।
नहीं पहला पार्ट एक ही प्रॉब्लम दिया है उन्होंने ये।
हाँ सर ये पूरा हो गया था, 7th वाला करना है।
हाँ 7th वाला करना है ना, तो अभी कॉमन क्लास है ना, तो ये उन डिवीजन का हो गया, इसलिए मैंने ये प्रॉब्लम नहीं लिया है। तो आपका 7th ही बाकी है, सिर्फ यही प्रॉब्लम आपका बाकी है सिर्फ। और जो उनको होमवर्क दिया था वो हमने अभी कंप्लीट कर दिया है, ये हमने इसमें कंप्लीट कर दिया ये प्रॉब्लम। ओके, कैन वी मूव ऑन? हेलो,
Yes, sir.
So,
a cylinder contains 0.45 meter cube of gas at 1 into 10 to the power 6 Newton per meter square and 80 degrees Celsius. The gas is compressed to a volume of 0.13 meter cube. The final pressure being
फोन करना उसकी
5 into 10 to the power 5 Newton per meter
ये
square.
क्या है यार, ये येलो येलो लाइट जाती है ना तो ये येलो येलो आ जाता
Determine the mass of gas. First, आप लिख रहे हैं सब जन?
yes, sir.
अगर आप सिर्फ स्क्रीन के ऊपर देखेंगे तो समझ में नहीं आएगा, आपको लिखना है प्रॉब्लम और मेरे साथ सॉल्व करना है। ये पीपीटी नहीं है, मैं भी खुद लिख रहा हूँ आपके साथ। मास ऑफ गैस, द वैल्यू ऑफ इंडेक्स, the value of index n for compression, third, the increase in internal energy of the gas,
बोल रहा हूँ मैं, देख हम ऐसे उसको स्ट्राइक करे जा रहे हैं, वही ना चिपक गया, तो ऐसे करके उसका चिपक गया, वही चिपक गया, देख फिर वो ऐसे माचिस जैसे उसने किया ना, फिर जाके चला यार से क्या कुछ बात है, जब ऐसे करेंगे फिर एक वर्ड जाएगा।
और फोर्थ है आपका the heat received or rejected by the gas, the heat received or rejected by the gas during compression. Take value of gamma is equal to 1.4, value of R is equal to 294.2 joule per kg degree Kelvin. हो गया सबका? Can we discuss?
Yes, sir.
Okay, what is given to you? They given a cylinder which contains 0.4 meter cube of gas. That means initial volume is given to you. .45 meter cube of gas at 1.1 into 10 to the power 6 Newton per meter square. That means P1 is given to you 1 into 10 to the power 5 Newton per meter square. What is temperature? Is 80 degree, 80 plus 273 is equal to 353 Kelvin. The gas is compressed to a volume of 0.13. So when it is compressed, volume must be less than V1. What is the V2 is 0.13 meter cube. And what is the pressure at that time? P2 is given to you 5 into 10 to the power 5. अगर आप पीवी डायग्राम निकालते हैं तो इस तरह से होगा ये 1 2 यस और नो आया ना ये देखिए यहाँ पर आपका है V1 और यहाँ पर है आपका V2 कंप्रेशन हो रहा है तो आपका P1 बढ़ रहा है P1 से P2 बढ़ रहा है यहाँ पर गॉट इट दिस कर्व यस और नो कर्व समझ में आ रहा है ना so we know V1 we know P1 we know T1 we know V2 and we know the P2 also that means 4 different parameters are given to you at the same time they given gamma is equal to 1.4 what is gamma is equal to Cp by Cv okay and what is R value of R is also given to you 294.2 joule per kg degree Kelvin okay what is R is equal to Cp minus of Cv ये पढ़ा ना हमने रिलेशन
Yes, sir.
अभी वो क्या कह रहे हैं फर्स्ट केस के अंदर डिटरमाइन द मास ऑफ द गैस यानी आपको निकालना है m फर्स्ट बिट में आपको क्या निकालना है व्हाट इज द वैल्यू ऑफ m ओके सो वी नो दैट P1 V1 is equal to MRT1 this is a perfect gas equation so m is equal to P1 V1 upon R T1 what is P1 P1 is equal to 1 into 10 raised to power 5 5 दिया है ना
Yes, sir.
10 raised to power 5 चाहिए यहाँ पर 6 नहीं ये 5 है यहाँ पर 5 कर दिए 1 into 10 raised to power 5 V1 what is value V1 V1 है आपका 0.45 R कितना है आपका 294.2 ये जूल में आना चाहिए ध्यान में रखते हैं किलो जूल में दिया है तो आपको जूल में कन्वर्ट करना पड़ेगा इनटू T1 कितना है आपका 353 so if you solve this you will get a value of m in kg all of you are getting all of you are with me yes or no
Yes, sir.
do the calculation tell me the value of m do the calculation tell me the value of m
स्पार्क आवे ना तो स्पार्क दिखाएगी आपका कार है ना मतलब मास में कार तो इनमें नॉर्मली कार में तो टायर वेल्डिंग करें तो मेरे ब्राइट आउट एकदम एकदम ब्राइट लाइट
what is m सिंपल कैलकुलेशन कीजिए फटाफट बोलिए मुझे क्या आंसर
0.43
0.43 राइट 433 actually kg no second what they asked in the second bit they asked the value of index n for compression okay what is the value of compression index of compression and expansion so we know the PVD relation हेलो कौन बात कर रही है
एकदम ऊपर रखो तो कार का ध्यान एकदम परफेक्ट
okay so what is the value of m is 0.433. Now, in order to find out the index of compression and expansion, we know that P1 V1 raised to power n is equal to P2 V2 raised to power n. That means V1 by V2 raised to power n is equal to P2 by P1. What is V1? 0.45. What is V2? 0.13. What is n that we need to find out? Is equal to P2. P2 कितना है? 5 into 10 raised to power 5. P1 कितना है? 1 into 10 raised to power 5. Solve this equation for the value of n and tell me the value of n. This relation we learned in PVT relation, that P1 V1 raised to power n is equal to P2 V2 raised to power n is equal to P3 V3 raised to power n.
Hello.
What is the value of n?
आते आते वो भी लेके आई ना फिर तो पी लिए पेप्सी को
होमवर्क देते थे नाइस
बताइए कितना वैल्यू? What is the value? बताइए जल्दी. हेलो, इतना सिंपल कैलकुलेशन नहीं करते आ रहा है क्या आपको? Yes, anyone is doing the calculation? हाँ बोलिए. ये कैलकुलेशन नहीं जम रहा है क्या? हेलो, all of you getting? What is the value of n? What is the value of n? Am I audible? Am I audible to all of you? हाँ सॉरी बोलिए।
सर वैल्यू लॉग में आ सकती है ना, लॉग में।
नहीं, यहाँ पर लॉग लीजिए ना दोनों साइड का।
यस सर। तो सर
लॉग ऑफ यहाँ पर आएगा n log of 0.45 divided by
तो सर
0.13.
1.296 है।
Yes, very good. 1.296. Okay. This is value of what we can say n. Now the third bit is what they asked. They asked the increase in internal energy of the gas. Now remember, always in the process of compression, the internal energy is always built up. Okay. So what is internal energy? Is called as del U.
सर
Yes,
ये
please.
वैल्यू ऑफ इंडेक्स क्या होता है सर?
Value of index यानी n ना, PV index of compression and expansion is represented by n. Okay, in the case of adaptive process, the n is represented by gamma. इसका हमने derivation किया है ना बेटा?
यस सर।
PV raised to power gamma is equal to C. And in polytropic process, this gamma now replaced by n. And this n we call as the value of or index of compression and expansion. Okay.
यस सर।
Okay. So del U. So del U is equal to. Hello, can you mute yourself?
Everything is looking at 2024. You have to find more British build areas and Kochi, Kochi is there only.
So del U is equal to M multiplied by CV multiplied by T2 minus of T1. Now we know the value of T1, but we don't know the value of T2. Okay. So how to find out value of T2? We know the pivot relation that T2 by T1 is equal to your V1 by V2 raised to power n minus of 1. This we know. So T2 equal to T1 multiplied by V1 by V2 raised to power n minus of 1. What is of T1? T1 is equal to your 353. 353. What is V1? V1 is 0.45. What is V2? 0.13. What is N? N is 1.29. कितना आया? N 1.296 minus of 1. So from this we are able to get the value of T2. Now remember, most important thing, that always convert the temperature in Kelvin and then use the values of temperature in Kelvin in the equation. If you are using degree Celsius directly, then obviously you will get the wrong answer.
Five 509.73.
509.79 Kelvin. Okay.
Yes.
Yes. Now T2 is known to us. Now we can go for the del U equation. What is del U? Del U is equal to M multiplied by CV multiplied by T2 minus of T1. What is M? M is 0.433. What is CV? CV is equal to R upon gamma minus of 1. CV is equal to R upon gamma minus of 1. T2 minus of T1. अब आप पूछेंगे सर इस CV is equal to R upon gamma minus 1 क्या आया, कहाँ से आया? This equation we already derived. Okay. Sir. When we saw the CP minus of CV is equal to R, उस time ये हमने relation हमने derived किया है. So we know the value of R, we know the value of gamma. So it is nothing but 0.433 into R is 294.2. Remember, this should be in joule. Okay. And gamma is equal to your 1.4 minus of 1 T2 mass of T1. T2 कितना है 509.7 minus 353. So if you want the answer in kilojoule, this entire term must be divided by 1/1000. तो आप इसको divided by 1000 कीजिए यहाँ पर. Akash, can you mute yourself? Akash.
अरे यार क्या है यार ये
Akash.
तो होगा
So then and then you will get the answer in kilojoule. So del U.
बस चलो बिना थोड़ा दूर दे वो थोड़ा सा दे 400 मेरे मना 600 मेरे इतना क्या करेगा पिला दो कभी दिन में किसी को हाँ
4.968.
नहीं ना. 0.433 into 294.2 divided by 1.4 minus of 1 multiply by 1000 multiply by 509.7 minus 353. नहीं इतना नहीं आता बेटा. 509.7 minus
49.6.
yes 49.608.
608.
This is value of del U. Now next bit they asked. What they asked? They asked the heat transfer. The heat received or rejected by the gas during the compression. That means value of Q. What is Q? Q is equal to the del U plus of W. ये अपने को पता है. So del U is known to us. So if we know the value of W, then we can easily find out the value of Q. But what is W? W is equal to your P1 V1 minus P2 V2 upon N minus of 1 for the polytropic process. And this is equal to MR T1 minus of T2 because P1 V1 is equal to MR T1 and P2 V2 is equal to MR T2. So it is MR T1 minus of T2 upon N minus of 1. So W is equal to, what is M? Is 0.433 into R, that is 294.2, okay, divided by 1000 because we want answer in kilojoule. Okay, if you want in joule then let it be, but we want answer in kilojoule. So 294.2 multiplied by T1. What is T1? 353. What is T2? 509.7 divided by N. What is value of N? 1.296 minus of 1 divided by 1000. So this will give the answer in kilojoule. अगर आपने 1000 से डिवाइड नहीं किया तो जूल में आएगा आंसर, ध्यान में रखो. तो you please try to maintain the dimensional homogeneity everywhere. कहाँ पर जूल में निकाला है, कहाँ पर किलोजूल में निकाला है और इक्वेशन में पुट करके कर रहे हैं, तो ये नहीं होगा.
सर अपन Q को MCP डेल्टा T से नहीं कर सकते क्या?
MCP
डेल्टा T से.
but value of CP is not given to you ना.
और सर वो CP माइनस CV R के इक्वल होता है ना सर. CV है अपने पास.
हाँ, then you need to calculate that all these values.
ओके सर.
वहां से भी निकाल सकते.
Minus 67.438.
Minus
67.438.
sorry 67 बोला ना आपने. Okay. 67.43. Okay. Kilojoule. Now value of Q. Q is equal to del U plus of W. What is del U? आपका कितना आया था? 49.9,
Said
49.608, sorry. 49.608 minus of 67.43. So you'll get value of Q in kilojoule.
minus 17.822.
Minus 17.822.
822.
So it is rejected. Negative sign. Okay. Next problem. So you need to solve this problem. Here at 1.02 bar, and 22 degrees Celsius, initially occupying a cylinder volume of 0.015, volume of 0.015 meter cube. So P1, T1 and V1 is given to you. Is compressed reversibly and adiabatically. Adiabatically means Q is equal to 0. Yes or no? Heat transfer in adiabatic
Yes,
process is always equal to 0. Adiabatically by a piston to a pressure of 6.8 bar. Calculate first the final temperature, second the final volume, third the work done. So the final temperature comes around. You need to solve yourself. I am giving the answer to you. Is
gamma नहीं दे रहा, gamma नहीं दे रहा.
air. So remember, for the air, gamma is always equal to 1.4, Cp equal to 1.005, Cv is equal to 0.718 kilojoule per kg Kelvin, kilojoule per kg Kelvin. So even if the values are not given to you, we need to assume all these values for air. आपको पता होनी चाहिए values. Okay? So please remember all these values. So the answers are, the final temperature is 507.24. Kelvin. Final volume is 0.00387 meter cube. Third, work done 2.751 kilojoule, and this should be negative, minus 2.751. So the same PVT relation we need to use, okay, and we need to solve this problem. So in the first case, you need to understand that the process is adiabatic. That means value of Q is equal to 0. They given is the value of P1, T1 and V1 and P2. So we can easily use the relation between the temperature and the pressure. So T2 by T1 is equal to P2 by P1 raised to power gamma minus of 1 upon gamma. So T1 is known to us, P2 is known to us, P1 is known to us, gamma is also known to us. So we can easily find the value of T2. Now once you know the value of T2, we can go for the P1 V1 raised to power gamma equal to P2 V2 raised to power gamma. And from that equation, we are able to get the value of V2. Once you know the V1 V2 and your T1 T2, we can easily find out the value of M. What is M? M is equal to P1 V1 is equal to MRT1. From that you will get the value of M, because P1 is known to us, V1 is known to us, R is known to us, and T1 is also known to us. So you will get the value of M. And once you know the value of M, then we can use the relation W is equal to MR T1 minus of T2 upon gamma minus of 1. So you know the M, you know the R, you know the T1, you know the T2, you know the gamma. We can easily find out the value of work done. Okay. So we need to play with the PVT relations. Please remember, the work done answer is not in kilojoule per kg. So you need to find out the mass of the air which is flowing through, which is inside the system. So if they ask find out the work done in kilojoule per kg, so no need to find out the value of mass. M is equal to 1. But here they asked calculate the work done. That means for total system, what is the work done? So we need to find the value of M, and that M must be multiplied by R multiplied by T1 mass of T2 divided by gamma minus of 1. Okay, so in this way we completed few problems. In next lecture, that is tomorrow and day after also, we will solve few more problems. Remember, for the examination, that means for the basic thermodynamic paper, the unit number 1 is your syllabus. Whatever the numericals up to the Saturday, okay, we will complete all up to that point, and numericals, your portion will be there for the examination. I think all of you received a textbook. Yes, textbook मिला है क्या आपको?
Yes, sir.
So you can refer the chapter number 1 for the theory and chapter number 3 for the theory, derivation, and for the numerical. Okay. And what are numerical I am taking? Please work out on the similar type of the numerical from the chapter number 1 and chapter number 3 from the textbook Thermal Engineering by R.K. Rajput. Okay. It is okay to all of you?
Yes, sir.
Okay. So CR, division 1 and division 2 CR, please float the attendance on my WhatsApp number.
Yes, sir, sure.
Thank you very much.